Okay, once again, I didn't get a chance to explain to you the actual formula that is used. We only talked a little bit about how angle and distance are interchangeable based on a unit circle as our, I'm going to say, our standard. Oh, once I finish this, sure, I'll give you this paper. Okay. Yeah. So what I want to add is this little portion. So if you want to think about this angle in terms of a distance, so I'm going to refer to this as units not in degrees, but this thing called radians. Okay. And by definition, I'm going to read it right here. A radian is a measure of distance around a circle. By specifically, here's a funky way of describing radians. A radian measure of an angle is the length of an arc, so we'll call it A for arc, that subtends the angle divided by the radius of a circle. Like what? Let me give you a visual of what they're trying to say. If I have a circle, and if I have a radius, the arc length, so how about we call it, let's stop right there. The arc length of that little piece, or like a pizza slice, is related to, or is equal to, rather, the radians of this rotation. So the distance, we can write it in terms of radians instead of angles. That might sound a little bit weird, or maybe I'm not explaining it properly, but here's an example, okay? Instead of writing it this way, how about I rewrite it like this? Your rotation, yes. Yes, I do. Come get it. Oh, sorry, Aline as well. You know what? Sure, come get one too then. I will have my little colored version available online. So if you miss something, then you can always capture it there. Okay. Okay. So you can say that your rotation is equal to your arc. So your distance traveled divided by r, right? Distance traveled divided by the radius. As an example, let's talk about a rotation of 360 degrees. Okay. If I traveled full 360 degrees, what is the distance that I traveled then? No, like distance, circumference. What would be the circumference if I traveled, it rotated a full 360? Right? 2 pi r, because you don't know what the circle is, right? So the distance traveled will be 2 pi r. But if I divide that by the r, what's left? My rotation is full 2 pi of the circle. That's all it really is. Let's do a different distance this time, just to get a better understanding of how this formula works. Give me another distance. Give me an easier one. 180 degrees, so half of a circle or a quarter of a circle, what would that equal to? Okay, half of a circle is? So if circumference is equal to 2 pi r, then half a circle is pi r, right? So my rotation in radians is equal to half of a circle, half the distance of a circumference, divided by r. So my radians is going to be just pi radians. This is what this formula is trying to say. It's just a relationship that you already know, but it's written in I guess, as a formula, so it might seem confusing. Okay. And to be honest, you only need to employ this equation or this formula only in specific situations. The biggest concern that you ought to have right now is to be able to go from radians and degrees very quickly. So yesterday, I asked you to try a couple of questions. Go to the back. We have this. We'll do one more. And know that the homework, the answers for these questions are already posted online. Choose another one that seems a little bit annoying. Anyone? You, sure. I'm annoying. It's okay. Anand hates me. Sorry, I'll live somehow. Negative 105. And since the degree is what we're trying to convert out or to disappear, 180 degrees will be in the denominator and the pi will be on top. Let's reduce. I'll do the easiest one. Divide both by 5. This becomes a negative 21. This becomes 36. Can I go further? Another 3. That's a negative 7. That's a 12. Can I go further? No. So that is equal to negative 7 pi over 12. And I know at this point, 99% of you, this makes more sense, negative 105, than this. I get it. If you want to stick with degrees, and I encourage you to do so until you get more used to fractions, be able to convert very quickly. We're going to go the other way, and you will find that this is a lot more manageable. Going from radians to degrees is so much more fun. Okay? Yeah, that's the distance I traveled along the outer of a unit circle. Yeah. That's it. So this would be in radians. Radians, or rad for short. So again, I'll just say it very quickly. Sometimes there are situations possibly in your future where you are doing trigonometry not based on the angle rotated, but literally all they will give you is how much of the distance they walked or something along those lines. You have to work with measures of distance, not an angle. So you have to be able to work with both because both can solve the question. They're just opposite sides of the same coin. Yes? So to do something, I do like the degree over. Yeah, essentially what you're doing is multiplying with the conversion factor, right? Multiply with the conversion factor. Yes, and to simplify. If you remember, again, this all goes back to the practice you might have had in science class, right? In grade 9 electricity and space, you have to convert from kilometers to, light years, for example. Do you remember that stuff? It's just unit conversion. So think about it like that. Let's go backwards. Exercise 2 asks you to take these radian measures and convert to degrees. So we'll start with one that seems manageable. A. Pi over 18 is the radians. If I want to convert into degrees, well, I want to get rid of the pi. Think about it that way. So pi this time is on the bottom. Notice how it's a little different from the previous questions. And I'll do this in pink to show that it's slightly different. I'm still multiplying by a 1, right? Because proportionally, 180 degrees and pi is equal to each other, quote unquote. So pi and pi disappear, divide by 18, divided by 18. Pi over 18 is equal to 10 degrees. Pardon me? Sure. When I'm converting radians to degrees, I am multiplying by the same conversion factor, but notice that it is a reciprocal. 180 degrees is on top. So when pi is going to divide by a pi, it becomes 1 and 1. And then 18 and 180, well, they have a common factor of 18. I'm going to divide bottom by 18. I'm going to divide top by 18, and I get 10 and 1. So just multiply across. Okay. Let's do something a little bit more complex. Here is, you may see, what are some of the ones that you might see more often? Oh, W? Nah, it's not that often. Oh, just something simple. Let's do D. Okay, pi over 6. You should recognize that already. No? Pi over 6 from our special triangles. Oh, what am I saying? We haven't done 4.2 yet. Ha, 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 ha. Pardon? It's where we're going to start off. Yep. Yep. Pardon? What is everything over 180? You mean here, this part? Why is it always 180? Well, we are multiplying a conversion factor, Mika. We are trying to convert from degrees to radians. So if you remember, here's an example. If I have 2 hours and I ask you, how many minutes is that? What do? We're going to multiply it by 60. Why? Because 1 hour and 60 minutes is exactly the same thing. So I'm actually multiplying it by a 1. You see? In the same way right now, I am multiplying by a conversion factor of 1. But the units end up changing. That's what we're doing. I can take a look at this once again after this lesson if you like, right? But this is all from my little thing right there. We're multiplying by a conversion factor. Check. You could, again, you can, I'll tell you right now, you will be able to survive grade 12 without doing radians at all. Just convert to degrees and calculate and convert back. Not a problem. But the more used to you get, the more proficient, I guess, you get with radians, just looking and recognizing the questions, you'll just be a lot faster with it as you progress into university. So I highly recommend you still try and practice. Anytime their time is not an issue, try it. Yes. Which one? B? B? Sure. Explain what? Pi over 6 multiplied by the conversion factor, 180 and 6 is reduced to 1 and 30. You said B, correct, Ednan? Okay, B. 3 pi over 2, I am going to multiply with a conversion factor. And I ask everyone to just reduce it by yourself. Pi is on top, pi is on the bottom. They will divide into 1. Leaving me with 2 on the bottom and 180 on top. I'll divide. 1, 90, 270 degrees. 3 pi over 2 is 270 degrees. So 3/4 of a circle. Yes, sir.
I'm confused.
Why?
I don't know how you got to 27. How you got to not like how you got to.
Well, I'm multiplying fractions. It's 3 times 90, and then 1 times 1.
Oh.
It's just a fraction.
Oh, so you're just canceling out the multiple.
Yes,
Okay.
yes. Stuff that you might have seen before.
Yeah.
All right.
Can you do what?
G. Sure. Can you do G or K? K is harder. I'll do both very quickly. And these will be my last examples. Okay. Have fun. All right. So, same thing, conversion factor. And now I'm pretty sure you're getting the hang of it. It just pi and pi disappears, and you just gotta simplify the numbers. 180 and 4, a denominator of 4, you'll probably see relatively often, frequently. So get used to it. Divide that by 4, you get 45 degrees. To multiply across, we get negative 135 degrees.
All right.
Last one, again, pi divided by pi is a 1. 12 and 18. 12 could be a number you see a little less often, but it's still around. That becomes a 2, and that becomes a 30. Think about it. And then you can continue on. Maybe that's a 1, and that's a 15. Whoa, multiply that across. 23 times 10 to 30 times 5 is 1 is 15, 2, 15, 3, 45. There you go. Isn't that funny? All of these we've done so far is within 360 rotation. Of course. For example, take a look at this one. Forget the pi. What's 23 over 6? Is that larger than 2? Yeah, it's almost -4, right? Remember, 2 pi is 1 rotation. So this is almost 4 pi, so it's going to be almost 2 rotations. Yes, Anna?
What happens if the denominator is divisible by 1?
Then it'll just have to be the same. But you know what? It'll almost always be divisible. Let me explain why. Other than 7, absolutely. Other than 7, it'll almost always be divisible. Does anyone here know why 360 was chosen? That's exactly right. Did anyone else know? Try it. What's the nicest large number you would want to use? I'm going to do this on a scrap piece of paper. Well, someone has to distinguish it. Like someone has to have said, let's do 360. So I want to save this. No, but seriously, why was it 360? Well, if I want to think about a large number, 100 would be nice, right? If it's a full circle is 100 degrees, how much is a quarter? 0, 25, 50, 75. Well, what's pizza slices, right? What is half of a quarter? That's not a nice number. So let's think of a number that is divisible by 4, but also divisible by 8. So that these pizza slices, will not give me a decimal. 4 and 8. 100, it could be 32, yeah. So, but also keep it as low as possible, right? So if you decided, let's say, okay, how about 120? Right, 120 would be 30, 30, 30, and 30, which is 30, 60, 90, and 120. And if you half that, half of 30 degrees is 15. Great. But you know that 45 degrees or half of an eighth is not always the angle that we use. What if we half that? All of a sudden we have 7.5 and then 7.5. It's annoying. So is there a number that's divisible by both 4, 8, and 12? So this pattern still continues to go on, right? And so we try to find a number that is divisible by as many numbers as possible. Let's just say from 1 to 10. Yes. 48. So you're saying each is 12, 12, 12, 12, and 12? Okay. So if I half it, that's a 6, and if I half it, that's a 3. That's great. That's great. What if I divide it by 3s? Because you know 30, 60, 90 is a good one. If I divide 12 by 3, I get 4. 4, 4, 4, 4, 4, 4, 4. That's good. What if you go smaller? 2, 2, 2, 2. Good. But as you get smaller and smaller, you know how small 1 degree is, right? Having this chunk pizza slice and calling that 1 degree, there's so much room for decimals in between that it may not be a good number. So at a certain point in time, I'm just making up the story, right? But all you have to know is 360 was chosen because it was divisible by so many pieces. It just worked without having to give a decimal. The only time you might see a decimal is if we divide by, as Anna said, a 7. So between 1 and 10, the only number 360 is not divisible by is a 7. It's not a bad number. Just sort of stuck. Yeah. It's the best story I can give you, just for you to sort of accept. But that's exactly it. All right, let's move on. Let's move on. The next piece before, oh my gosh. Do I actually only have? All right, here we go. A quick recap so that you know what to do. Remember this? The formula for arc length is that. Okay, so for A, let's just plug in the numbers. Theta is 0.8 radians. Radius is 12. What is the distance that I traveled? If it's not, notice how this is not a unit circle. So this time it's 0.8 is equal to arc length divided by 12. And of course, you can multiply both sides by 12. The arc length is therefore 9.6 centimeters. So I walked 9.6 centimeters. I want to give you a visual of what 0.8 radians actually is, because some of you might still be a little confused. What is that in degrees? What is that in degrees? Someone do that on the calculator? 0.8, multiply that by 180, divide that by pi. Russell? 144 degrees. So if I had a unit circle, oh, sorry, not a unit circle. If I had a circle and pi over to 1.4, 1. Yeah, you know what? You're right. It can't be over 90 degrees. Can you do that one more time? Ah, yes. So yeah, 180 divided by, multiplied by 0.8 divided by pi. What does that equal to? Would you? 45 point. Okay, so about 46 degrees. What I'm trying to say is if this radius of a circle is 12, I multiply. No, we forgot to divide by a pi. So it's 0.8 times 180 divided by pi, 3.14. Gives me 45.8 degrees. So in a circle with a radius of 12, if I don't want to confuse you, so I'm going to erase that. If I walked a rotation of 45.8 degrees, the distance I would have walked would have been 9.6 centimeters. That's what it's saying. The arc length. That's what radians is, yes. If this was a unit circle, that would have been 0.8. But since it's not a unit circle, we multiply that by 12, we get 9.6. That's all it is. That's what radians is. It's a measure of distance. As another example, if you take a look at G, this time they give you different, so that's A. If you look at G, this time they give you the arc length as 4.6 centimeters, and my radius is 2 centimeters. The radians would be 4.6 centimeters divided by 2, which is 2.3 radians. So depending on what the question gives, like, it shouldn't be difficult to find a number. The concept might be a little confusing because it's new to you, but applying the formula in itself would not be confusing just yet. Okay. All right. Looking at where I want to go, clear I won't be able to finish 4.2. And in terms of our calendar that I set up, I do have time for 4.2 tomorrow, and then I have rest of 4.3 finished. Okay, you know what? I think we can do this. What I want to do today is let's just finish highlighting the parts from last year, grade 11, as a way to introduce. I think it might be a good opportunity for you to see just how much you should be coming into grade 12 with. If this is a little bit weird, you have today to sort of practice it because I'm not going to give you that much homework otherwise. And I also, if you notice at the back of this package, I gave you questions that I would have given to my grade 11s after doing our CAS rule lesson. The answers to this is already online as well, so you can practice that if you're feeling shaky. Let's do this. Do you remember your special triangles? If the angles were 45 degrees or 30 and 60, the numbers would be blah, blah, blah. I am actually going to make an effort to write all of these angles in radians. Bear with me. 45 degrees is the same as pi over 4. So if you see pi over 4, it's 45 degrees. And of course, the first special triangle is isosceles. The easiest value that we can give a side is 1 and 1. And by Pythagorean theorem, the hypotenuse is √2. There's the first special triangle. Who here, some people saw it if they were in my class, who here learned your special trig angles strictly using special triangles? Who just memorized the special triangles? Sort of. Who has a different way of doing it? Like, did anyone show you a chart? I showed my class a chart. It depends. Okay. All right. Let's continue. Next, this would be 60 degrees or 100 pi divided by 180. It would be pi over 3. And then 30 degrees is pi over 6. So 3, 4, and 6, try to get used to it a little bit. Does anyone know how to do this triangle without having to memorize it? No? I don't memorize my special triangles. I solve it on the spot. Let me try to explain. All I memorize is the fact that my first triangle is isosceles, which makes these angles equal. So what is the only angle I can put in here? 45 and 45. Okay. What is the easiest number that I know? That's not a 0. So 1 and 1. Doesn't it make sense? Because they're isosceles. And then I can do Pythagorean theorem in my head. I know that's a root 2. I didn't memorize a thing. I just know that it's isosceles. Right? Yes. Here's another way to memorize the other triangle. Instead of isosceles, I think about an equilateral triangle. And not 1. What's the easiest number after 1? 2, 2, 2. You with me? I'm going to cut this in half. And of course, I forgot to tell you that in an equilateral triangle, it has to be 60, 60, and 60. But if I cut this in half, what does this angle become? 30. If I cut this in half, what does that length become? 1. So automatically, this becomes 1 and 2. And by Pythagorean theorem, you can figure out the side, it becomes root 3. I hate memorizing. And so I figured out ways to get around it. If it doesn't work for you, that's okay. That's okay. If you just want to write this on your cheat sheet, that's okay too. Okay. With this, you should be able to tell me the exact measures for sine 30, 60, and 45, cosine 30, 45, 60, and tangent 30, 45, 60. However, even if this is even more too annoying for you, I propose a different way. When I was in high school, my teacher showed me the chart method. In fact, it wasn't just my teacher, my sister actually showed me the chart method, and it stuck with me because, I learned better from my sister. Anyways, if you don't like triangles, I recommend this. I like you to write 0, 90 degrees, and then 30, 45, 60. So from smallest angle to largest angle. I am going to write it in radians. This is pi over 2. This is pi over 6, pi over 4, pi over 3. And in case you forgot, that's 0 degrees, 30, 45, 60, 90. So this chart is supposed to tell you what is sine of 0 degrees, what is sine of 30, what sine of 45, what sine of 60, what sine of 90. Same thing with cosine. Cosine of 0, cosine of 30, cosine of 45, cosine of 60, cosine of 90. Now, I wouldn't show this to you if it didn't save you time, so listen carefully. In the 4 corners of your empty box, in clockwise, can you write 0, 1, 0, 1? Can you do that? Next, in small letters, please, small numbers rather, in clockwise rotation, 1, 2, 3, 1, 2, 3. 1, small numbers, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. the 6 numbers, 1, 2, 3, 1, 2, 3, square root all of them. So the 1 I can square root, but square root of 1 is 1, right? Square root, square root, square root, square root, square root, square root. And if you want, you can square root this too, just whatever. And then all the small numbers, divide it by 2. There you have it. So it's a special triangle. It's the stuff that you might have learned in grade 9, grade 11, sorry. Remember that? Amazing. Watch the video. Pardon me, Jack? Yes. So square root of 1, square root of 2, square root of 3, square root of 1, square root of 2, square root of 3. So choose something. We'll test it. Let's take a look at cosine of 30 degrees. If you look at your triangle, cosine of 30 degrees is adjacent over hypotenuse. Cosine of 30 degrees is root 3 over 2. Root 3 over 2. Take a look here. Sine of 45 degrees is opposite over hypotenuse. So it's 1 over root 2. But 1 over root 2 is not a good habit to have a radical as a denominator. So if you simplify, or rather you normalize it, okay, you multiply it by a 1, you get yourself root 2 over 2. They are the same thing, and so you have your answer here. Just root 2 over 2. Okay. Please also note that this chart does not have sine over cosine. In other words, it doesn't have tangent. It simply assumes that you can put the two fractions on top of each other. Now, if you don't want to do that, then you have no choice. You're gonna have to memorize your special triangles. If you don't like to put, a fraction on top of a fraction and simplify it, use your special triangles. Any questions so far? Please note that this is still grade 11 review. Okay, you have done cast rule last year, and you should be bringing something to this class. You may not remember all of it. That's fine, but you got to recognize things at least. Yes, Mika. Yes. 30, 60, and 30, 45, 60, and of course 90 as well. All of it's in there. 90. Okay. We will look at this one more time tomorrow. Okay, just a little bit longer. But I do want to cover Castro so that you at least have something to try these back page questions if you, in case you want to review. Please remember, on a circle, on a given point, if I rotate a certain angle right here, that point of X and Y represents the height of my triangle and the base of my triangle. In other words, from theta, this opposite distance is Y, and my adjacent distance is X. Right? So again, my radius is hypotenuse, my opposite is Y, my adjacent is X. So what is sine theta? Opposite over hypotenuse. What's opposite? Y. What's hypotenuse? R. So sine theta is the same as just the y value divided by radius. Cosine is adjacent over hypotenuse. Instead of talking about adjacent and hypotenuse, we're now on a Cartesian coordinate. What is the adjacent side? X. What's hypotenuse? Radius. And lastly, tangent is opposite over adjacent, and that is the y value over the x value. That's it. Who remembers what CAST rule is now that we've established the positive x, positive y, positive r for SOHCAHTOA? Lillian? Right. So sign suddenly changes is what Aline is saying. If I do SOHCAHTOA in this quadrant or a triangle in this quadrant, some values might be negative. Why? It's a rule and some of you might have memorized it, but where did that come from? Take a good long look at the letters here. Adnan? In the quadrant, x is negative. So which of these three use x? Cosine, tangent. Let me explain. If I draw this exact triangle on this side of the circle, it's the exact same y value, right? I have the same height. I also have, oh, sorry, let me draw this. I also have the same base length, except because this is a Cartesian coordinate, we're on the negative side. It's the same value, but it's negative. So let's talk about this angle for a second. If I'm dealing with the same angle here, let's say that's like 30 degrees, angle of 30 degrees, but it's in quadrant 2, sine is opposite over hypotenuse, a positive y over a positive r. Nothing changes. But for cosine being adjacent over hypotenuse, it's a negative x over an r. For tangent, it would be y over a negative x. In short, for the first quadrant, everything is positive. But for the second quadrant, only sine is positive. Using this same idea, I'm quickly going to fill in this sheet so I can let you go. Sine this time is still has a negative y value, so it's negative y over r. X is still negative, it's negative x over r. Tangent is negative y and negative x, which turns into a positive. This one, the y value is still a negative, so it's sine negative y over r. Cosine, the x is positive again. So this is going to be positive x over r, and tangent is negative y over a positive x. In the fourth quadrant, cosine is the only ratio that's positive. Therefore, we have C for cosine, A for all, S for sine, and T for tangent. So we have CAST rule. I didn't get a chance to do any of the example questions. I didn't get a chance to talk about the other terms. Oh, there's a typo. That's a pi over 2. I'll talk about it tomorrow again. It's a pi over 2, not a pi over 4. If you want to sort of refresh your memory, try any and all of these and check the answer key online. I am also expecting you to be very proficient with unit conversion. All the answers are placed online. So if you can do as many of these as possible, you will not hate yourself for it, okay? You're doing yourself a favor. I will see you all tomorrow. Tomorrow is Wednesday. Okay, you're not grade 9. Okay, I was going crazy. All right, we'll see you tomorrow morning. You are dismissed.